Welcome to session 8, part A. In this part, what I'm going to do is finish up with chapter 5 and talk about two small topics that finish off the chapter. One is just to talk about how interest rate and the market or the quantity or the demand and supply for borrowing, how much money is borrowed, can be done with the tools we've already learned, just the demand and supply curves. And we can talk about how the interest rate is set. And then finally, one other little point is a thing you should all know is what we mean when we say the real interest rate versus the nominal interest rate. Um, Before I do that, quick a joke. It involves a joke about economists. So the joke is that a physicist, a chemist, and an economist are all stranded on a deserted island, and all they have to eat is a can of beans. And the problem is they don't know how to open the can of beans. And the physicist says, "Well, wait, I've got an idea. I've done the calculations. I realized if we climb this tree, we drop the can on this rock. I've calculated the exact height it should be that will just put enough force on the can that will open the can. We can eat the beans." Chemist says, "I think I've got a better idea." Said, "I've calculated the molecules in the can, and I've realized that if we heat the can at this amount, at this temperature, the top of the can will pop open and we'll be able to eat the beans." And the economist says, "You know what? I think I even have a better idea." And they say, "Well, okay, explain that." And the economist says, "Well, first, assume that we have a can opener." Okay, so that's the joke that economists like to make these Herculean assumptions. And uh, yes, it's true, we're guilty of that, but in our defense, often we're doing, especially in classes, when we make these assumptions, we're making assumptions to make the problem more simple. And if we didn't make these simplifying assumptions, it would just be too difficult for students to understand. So often I'm going to make an assumption about, I'm going to call the interest rate, like there's only one interest rate in the economy. And really, when economists do analysis, professional economists, those of us with PhDs, we don't always assume that. We assume, well, there can be varying interest rates. But the problem is when you do that, the models are just so much more complicated. And when you're trying to teach something to students, it just becomes way too complicated. And it's easier to learn if you can make these simplifying assumptions. Physicists, by the way, do the same thing. In fact, every time when you learn about the law of acceleration and gravity, you learn in physics classes that if you drop something on the Earth, near the surface of the Earth, in a vacuum, the object will fall, it will accelerate at a rate of 9.8 meters per second squared. And there's a formula for how to calculate the position of that object, and it involves time squared times 9.8. Um, Now it happens though that is the formula for when something is dropped in a vacuum. And of course, the surface of the Earth is not a vacuum, so it's not quite that number. So, well, if it's a heavy enough object, it's close enough to a vacuum that it will be approximately true. Okay. Now it turns out physicists, they could use the exact formula that involves the air friction, but the problem is it's a much more complicated term. And so when you're doing an introductory class of physics, you just assume that it's a vacuum, even though the physicists will say it's impossible to have a perfect vacuum. Even in space, there will be tiny little molecules of oxygen and helium and hydrogen floating around somewhere. And so it's not, you'll never get a perfect vacuum, but you can come arbitrarily close to a perfect vacuum. Then your equations becomes a very close approximation. Okay. And that's what happens in economics. Maybe we're not quite as close an approximation of the truth as physicists, but we do the same exercise. Okay. So that's what's happening when we make these assumptions. Um, what I want to do now is talk about a concept in the book where we will learn about how to derive the interest rate, how that's the same technology, demand and supply curves that tell us what the equilibrium interest rate will be or the market clearing interest rate will be. Now, first of all, so I'm going to say, here's the point. So I'm going to talk about, we often say this, we'll say something like the price of some good, or I'll say the interest rate. And you may say, well, wait, that doesn't make sense. That means there's one interest rate. And of course, lots of us will say, well, I have one interest rate on the loan for my car. My buddy has a different interest rate for his loan on his car. My credit card charges a different interest rate. And then if you get a home loan, it's even a different interest rate. So, what do we mean when we say the interest rate? Well, what often happens when economists, what the book does, when we're going to talk about the interest rate, what we often mean is a interest rate on a riskless loan. Okay, so that means that a loan to someone who we can be certain is going to pay it back. Okay, so it's like a vacuum in physics. Maybe there's no such thing as a completely riskless loan, but we can become pretty close to it. And most economists will say um, U.S. government bonds are pretty close to a totally riskless um, loan. And the idea is that if I go buy a government bond, I can be pretty much guaranteed that the U.S. government is going to pay on that. The only way it would not is if the U.S. government became bankrupt. All of a sudden, the U.S. government ceased to exist. But we can be pretty sure that the chance of that, at least over the next year, is very, very small. Something like 1 in 1,000, if that. Um, so that's what I mean by riskless interest rate. Now, the analysis I'm going to do, I don't even have to assume that it's a riskless interest rate. The key is just that we have a constant level of risk, that we've clearly specified the level of risk. And here's what I mean by that. So it turns out that I happen to have uh, two loans where the collateral I've put up is my home. So I have two loans on my home. There's one that the legal term is the first loan, comes from I'll call the first bank, and the second loan comes from the second bank. Now it turns out the first loan, I have a rate of about 2.5%. That's my interest rate that I pay. The second loan is about 5%. Okay, now why is it two different rates? Well, it turns out when I wrote the contract, when me and the banks, when we entered into this agreement, it specifies on those contracts that if I ever go bankrupt, the first bank gets paid off first. So that is whatever money I have from, say, selling the house and other money I may have, that money is first applied that goes to the first bank, and then whatever is left over can go to the second bank. Okay, so those two loans have a difference of about 2.5%. So what that means is that the second bank thinks that the probability that I'll pay that loan off is about, the second loan off is about 2.5% lower than the first loan. Okay. But the key is, so when I talk about the interest rate, the key is that I'll talk about it for a riskless loan, but it doesn't have to be a riskless loan. The key is that it's just some loan where we've specified precisely the risk. I could say the market for loans where the risk involved is about the risk that Tim Groseclose has on his first loan for his home. Okay, the key is that you just specify it precisely. The book tries to be even more precise, more simple and direct, says let's just make it a completely riskless loan. Okay, so here's what we're looking at. So we're looking at the market for a loan in which the borrower is guaranteed to pay it back. Okay, so if we look at all those types of borrowers, Okay, we look at all the people who may be willing to make that loan. The analysis would go something like this. Okay, first we would say, what if the interest rate, let's say we're 12%. How many people would want to obtain a loan where the interest rate is 12%? Well, probably not that many. Okay, let's assume though that I'm giving an example that the total people who would do that is some number, and the total amount of money that they would want to borrow at that interest rate, let's say, is $0.1 trillion. Okay, so that would be, we're going to call it the demand, the quantity demanded if that were the interest rate. So let's say it's $0.1 trillion. That's how many people. $0.1 trillion worth of enough people would want to borrow $0.1 trillion if the interest rate were 12%. Now, what if the interest rate were, let's say, 7%? Let's say that at that rate, more people would want to borrow, and the total amount that they would want to borrow is $0.4 trillion. So we would have another point here, and then let's say, what if the interest rate were 2%? How many people would want to borrow money at that? Much more. How much money would they want to borrow? Let's say it's something like 1.2 trillion. So we'd have another point here. This is what we'd call the demand curve for borrowing those funds. Okay. This is the demand curve, and notice that it slopes downward. People would want to borrow more when the price, okay, sometimes people call it the price of money. The book says that's not quite the accurate term. The more accurate term is the price of borrowing. So if the price of borrowing is at various interest rates, as that interest rate goes down, more people want to borrow more money. That's the demand for money. Okay. So what about the supply of money? Well, the supply of money would usually come from banks. Where do the banks get the money? They get it from the savers, the people who deposit their money in banks. So let's think about the supply of loans. Okay, this comes from banks. Actually, there's a few more institutions that would do it. Particularly later on, we'll talk about the Federal Reserve Bank. So let's forget about that for now. Let's just suppose there's a bunch of private banks out there. And let's assume that something like if the interest rate were at 2%, then let's say that banks would be willing to lend 0.4 trillion. 1%, they'd only do 0.1 trillion. 2% is the rate, 0.4 trillion. Let's say at something like 0.9 trillion. If the interest rate were 5%, banks will be willing to lend 0.9 trillion. Okay, and so on. Let's say at 9%, they'd be willing to loan 1.2 trillion. If we continue writing these points on the graph, this is the supply curve. This is the supply of money that can be lent. Okay, so it would look something like this. And what we would do, this is the supply curve. We just look at this curve, and we would say, what is the market clearing interest rate? And the answer is we get about 5%. What is the market clearing quantity of money that will be lent? And it's about 0.9 trillion. Okay. The point is that all this analysis we've done for supply and demand curves, you can also apply it to look at the amount of money lent or borrowed and what the interest rate will be. All you have to do is, instead of where we normally had the price on the vertical axis, instead we put the interest rate. Okay, so That's all there is to it, and that's the final part of chapter 5. They call it the appendix. And now, one final point while I'm on part A of this session, I'm going to talk about what's called nominal interest rate, real interest rate, and inflation. Hopefully, everyone understands inflation. You've seen it on the news. This is the amount of the percentage increase that the price of goods increases or decreases over the course of a year. Okay, normally we live in a time where inflation is very low. It's something like only 1 or 2%. Other times have been very high. So I lived in the late 70s when early 80s, late 70s when inflation rate got up to 10, 12%. And in other countries, sometimes this inflation rate can get very, very high. But in the U.S., as I speak right now, it's very, very low. Okay. Next, the notion of the nominal interest rate. Nominal interest rate is what the banks report. That's what you see in the news or the newspaper or on websites. So currently, as I said, that when we say the interest rate for a riskless asset, I said approximately riskless asset would be U.S. government bonds. And so if you look up the interest rate for a 10-year Treasury bond, as I speak, it's currently about 0.7%. So it's currently about 0.7%. Okay. To make things a little bit easier, let's assume we're at a different time, about 2 or so years ago, when that rate was something like 4%. So it used to be. Now, if you look up the 10-year Treasury bond, Wall Street Journal, there's lots and lots of news services where you can look this up, and it will be about 0.7%. But a few years ago, or 2 or so years ago, it was about 4%. That was what is reported. Now, we economists, we don't call that the real interest rate. We call it the real interest rate just equals nominal interest rate minus inflation rate. Okay. Now, the nominal interest rate, you can look up, you can find that on websites. Inflation rate, how about that? Well, you can find that. In fact, usually the rate that economists agree on is what the Commerce Department computes. So I think it's once a month they do this. We'll talk about this more. I think it's something like session 20 of this, how the Commerce Department and other economic services measure the inflation rate. They look at the increase in prices for a bundle of goods. Commerce Department does this, reports it, I think once a month. And you can look that up. It's some official number, and it's something like, currently, it's something like 1.5%. That's the yearly inflation rate. So, if we were looking at 2 years ago, the nominal interest rate for a riskless loan would have been something like 4.0%. The inflation rate would have been something like 1.5%. And so that means the real interest rate is just the difference in that, which would have been, what it says, 2.5%. Okay. So that's the final point, how you calculate what it means when we say real interest rate versus nominal interest rate, and a taste of what we mean, what economists mean when they say by inflation. And later on, we'll talk about exactly how that is calculated. Okay, that's main concepts. End of chapter 5. Not sure I'm going to do a part C. We'll see how long I take, but I'm just going to do some questions from the back of the book. So I'll do that in part B. See you there.